Hi
Yeah,
Ritesh, how are you doing?
I'm good. How about you?
I'm doing good, thanks for asking. Okay, well, is that Anusha or Krishna in between?
Yeah. Hello?
Yeah, is there anyone who is gonna join apart from these two?
Yeah, Krishna Jan.
No, I'm
Hello?
asking about these guys. Apart from these two, is there anyone who will join, who will add more? Are there any other guys to join this session apart from these two?
Only two guys only.
Only two guys, okay. Okay then, one moment, let me share my screen. Eight four four two five four. Okay, are you able to see the screen?
Yes.
Yes, yes. Yeah.
Okay, fine. So firstly, what is a network according to you? Any ideas? What do you think of it? Think of a
Connections,
network?
like
Connections.
connections.
Okay. Any specific definition?
So, network is a connection of nodes, establishing communication between them.
Okay. You're correct to some extent, but connection of how many nodes?
Uh, may vary from two to like.
Correct. Okay. I'll put it across combining what you said.
Mhm.
It's basically an interconnection, two or more devices which are capable for communication, capable of communication for sharing information, you can say, or else for communication in the sense what is communication? Sharing some information is called as communication, correct?
Mhm.
Yeah.
Okay. Yeah. Any doubts in this?
No, no.
Okay.
No.
Now I said something about devices. What are these devices all about? Any idea?
It may be mobiles, computers.
Okay, basically you are correct, but there are certain categories of devices, namely
Okay.
end devices.
Device. Okay. Yeah.
This is the first category, and the second one is network devices. Okay, now under the end devices, you have your PC, laptop, mobile phones, printer, etc. Also server. Okay, you can say etc. There are many others involved, and under the network devices, we have router, switch, hub, firewall, load balancers, etc. You have many other devices as well, but for now we'll consider this. Okay, so firstly, I have given you the definition of a network, which means interconnection of two or more devices. For communicating, at least I need two, right? Minimum two. So it could be more than two as well, for sharing some information. And what is that information all about? That information consists of some files. Under the files, you have videos, audios, etc. Email, something like that, etc. That email is a mode where we share the files, videos, audios, something like that. Now, well, if you get back to ages ago, where a network was not introduced, how the communication used to happen? Any idea?
Person to person, or messages like
How come?
mails.
Remember pigeons?
Yeah.
Those
Yeah.
I'm talking about ages ago.
Yeah.
Ages
Yeah.
ago, in the
Understood.
sense ancient times, wherein
Mhm.
pigeons were involved carrying some data. Okay. So what was the disadvantage really? Firstly, we'll discuss the disadvantage of those
Lost
medium,
data,
of that medium specifically. Okay, something you mentioned. What is that?
like loss of data,
Okay,
like not
loss
a
of data.
reliable method.
Okay, not reliable. Next,
Limited amount of information, like very little information can be
limited amount of.
information, like
Okay,
and time, like it takes more time.
okay, more time,
Yeah, time taking.
which means slow, right?
Yeah. So,
Mhm.
Any others?
security, like anyone can.
Okay, security problem. Anyone can modify the data in between.
Yeah.
Any other things?
Short distance
Correct. Short distance.
comparatively, I guess.
Okay, these are all the limitations ages ago. In order to avoid those limitations, networking was introduced. Firstly, depending on this limitations, we have a couple of advancements by introducing the network. First thing is security. Okay, how this security is introduced, how this security actually being made, or how this security is enwrapped or encapsulated by using certain algorithms, which is called just like AES, Advanced Encryption System. Okay. Next, DES, Data Encryption System or Standard Triple Data Encryption System. Okay. These are certain algorithms involved in order to secure that particular data. Okay. Now, this being security, next thing, reliability. What does this term mean? Any idea?
Um,
Like
retransmission or
dependency,
Let's say if I'm calling your name.
privacy most probably.
No, it's not about privacy. It's about response. If I'm sending any data, I'm expecting some acknowledgement. Why
acknowledgement.
I'm expecting some acknowledgement? I need to be sure, right? I have transferred the data and it has reached to you.
Yeah.
So how would I get that assurance? Depending on your response, correct?
Yeah.
So that is what is called reliability. Meaning if I'm sending any data, I'm expecting some acknowledgement. Next thing, fast communication, right? It's
Yeah.
next, more amount of data can be exchanged. There's no limitation. How about the distance? Scalability. Scalability means it is spread over large area.
Mm-hmm.
Okay. Let's say if I'm sending any data and it has lost in between, what I would do? I would,
Retransmission.
okay, in case of network retransmission is possible.
Mm-hmm.
So depending on this limitations, advancement has been introduced, which is network. And these are the advantages which I mentioned over here. Okay. Is everything clear up until this point? Or do
Yeah.
you have any
Yes,
doubts?
No.
Okay,
it's clear.
fine. Now, what are the basic components required if I want to communicate? So firstly, I would require a sender. I would require a receiver to receive the data. I would require a medium of exchange. Okay. And apart from that, I would require actual data, which has to be exchanged.
Yeah.
Correct?
Mm-hmm.
Yes.
So it could be exchanged from this device, let's say device A to device B, or device B to device A, which means vice versa as well. Correct?
Mm-hmm.
So how many things? First one is sender. I would require a sender. I would require a receiver. I would require actual data which is exchanged. And I would require a medium. So basically, these four things are compulsory, right?
Yeah.
And one more thing, it's it's up to me if I want to deliver the data in plain text or in ciphertext. Well, what is the difference between plain text and what is ciphertext? Any idea?
So ciphertext is modification like manipulation of original data so that except for the receiver, no one can understand it.
Exactly, correct. Awesome. So ciphertext means, let's say this is the data, for example, DATA. In ciphertext, I would send that the same data in something like this format, so that firstly what happens is once this is received on the receiver's end, he'll apply an algorithm to decrypt it so that he'll get this value data. Okay, only then this is secure. And one more thing, only that person can decrypt the data who has the capability and who has the keys. For example, let's say for example we are roommates. Okay, we have two keys, one with me and one with you. Only that person can open the room, right, who has the keys. In the same way,
Yeah.
only that person
Yeah.
can decrypt the data who has the key. There are keys involved for encryption and for decryption, for both. Okay,
Mhm.
so depending on that, he can encrypt or decrypt, depending on the requirement as well. Okay, for example, there are two terms. Uh, well, just as an example, I am taking those two terms for remote service. Okay, for taking the remote access of the devices, we use two protocols, namely one would be telnet and the other one would be SSH. If you take the access with telnet, okay, there the data exchange is in the form of plain text. If you take the access using SSH, there the data exchange is in the form of ciphertext, which is encrypted with keys. So this is just an example, just to make you understand. Okay, you don't have to you don't have to worry about it. Definitely, I'll explain these two things in forthcoming sessions. Okay, for now you understand it in this manner, just as an example. Okay.
Okay.
Am I clear
Yeah.
until this point?
Yes.
Yes, you are.
Okay, fine. Now, after this, what are the types of communication? Any idea?
Like audio, video, those types of communication.
No, those are all the examples. I'm not talking about examples. I'm talking about the types.
Okay.
Then I'm not sure.
Okay, no worries.
Yeah.
One moment. Okay, under the types of communication, you have okay. Have you ever heard these terms?
Yeah.
Apart from unicast, I heard the rest.
Okay, no worries. Unicast is nothing but one-to-one communication.
Mhm.
Only between the two,
Mhm.
one-to-one.
Okay.
Coming to broadcast, it's one-to-all.
Okay.
For example, TV, it's one-to-all, right?
Mhm.
Mhm.
And if you talk about multicast, it's one-to-many.
Many.
For my understanding, I write it as
Specify the group.
Yes, one to specific only. Reason why I'm saying one to specific only. Let's say right now we have joined our Zoom session and we are discussing certain topics. For example, your you have switched to speaker since your earphones or headphones are not working. Okay, your parents might be passing around. Do they understand what we are discussing?
Yeah.
No,
Do they listen
maybe.
what we are
Yeah.
talking? But do they understand really what we are discussing?
Okay. No.
So this is the example of one to specific.
Okay.
Okay. So this is for my understanding for simplicity. I actually what we call simplify it in this manner, one to specific
Specific
only.
one.
Generally people call it as one to many. Okay.
Okay.
Now in networking, remembering is very important irrespective of how you remember. Okay. So I remember
Okay.
it in this manner so that I won't be confused. Fine.
Okay.
Now, these are the types of communication. And what are the modes of communication? Any idea?
Wired, wireless.
Under wired and wireless as well, we have modes. I'm talking about those modes.
Ethernet, like you asking that? Ethernet.
No. Okay, no
Okay.
worries. I'll let you know. Have you ever heard this term? Simplex,
Okay. Yeah.
duplex,
Multiplex.
or full duplex,
Full duplex. Okay.
half duplex. Have you ever heard these terms?
Yeah. Like
Yeah.
I'm not sure about the simplex, but half and full duplex.
No worries. Say simplex is similar to unicast communication.
Okay.
I guess whoever is talking, your voice is breaking out.
I'm not talking.
Okay.
Okay.
I think my voice.
Showing internet connection as unstable. Yeah. Now, simplex is one-way communication.
Okay.
One-way communication means you can say, again, I would take the example of radio or TV. That is one-way communication only, right?
Yeah.
Next, half duplex means two-way but not simultaneous.
Okay.
For example, walkie-talkie. Next, duplex or full duplex is simultaneous two-way communication. Okay, simultaneous two-way example, your mobile phones. Fine. So this is all about communication, types of communication, modes of communication, and then components of communication. Now, once this is complete, I believe this is done. We are done with the communication part. Okay. Any doubts in this?
No.
No.
Okay. Now we'll start with types of network. Any idea? Okay. Under types of network, we have LAN,
Okay.
WAN. So under the WAN, we have PAN, CAN, MAN. So these types. Generally, LAN stands for local area network. It covers small geographical area, which is of 100-meter range. Now, about the WAN, people say connection of multiple LANs for simplicity. Reason why? Because it covers large area.
Okay.
Now, under the WAN, there are certain divisions up to where you want to limit specific network. For example, people say I am in campus. So for that, for only that specific campus, you have campus area network. Okay, wherein that is specified to certain range. Again, this is mixture of what? LANs. Up, up to what range? That depends on the building or the campus area. And also there is one thing called MAN. MAN means Metropolitan Area Network. It is specific to city.
Okay.
So depending on, again, it depends on the area which the city is covering. So also that is mixture of lands. So there are different types based on the type and the area. Those are given as different names, but basically there are only two things, either LAN or a WAN. Okay. Specifically as a network engineer, we deal with these two things. Reason why only these two things, rest all are given by whom? Service providers or internet providers for whom Wi-Fi is required. Okay. But for us as a network engineer, we only concentrate on these two.
Okay.
Now, after this is done, okay. Now, I'd like to show you. Have you ever heard this term?
No.
Okay.
No.
So, how this network communication is established? Do you think that with the large cable which are laid from the top along with the what we call electricity wires, uh,
No.
then how do you think this would be fast? By laying the cable
I think
underground?
it's I think it's from with cables
Hmm.
underground. That's the fastest way of communication.
But not exactly. It's cables laying, it's by laying the cables under the ocean or under
Ocean.
the sea.
Yeah. Hmm.
Have you seen those?
Yeah, and I mean, like, I know about those cables, but I haven't seen any.
Okay, you can Google it and see how the submarine cables are laid
Okay.
from the sea. Okay, so this is how the communication is too fast, and there is hell lot of reliability over there. Sorry, not reliability. I forgot to discuss one important term over here under advantages.
Redundancy.
Have have you gone through
Uh,
this term before?
yeah, I forgot about that. What is that?
If one path goes down,
Okay, yeah.
I need a backup, right?
Mm-hmm.
So with this submarine cables, there are hell lot of backups involved. If you ask me, they always keep laying these submarine cables under the sea.
Okay.
Okay, so because of those cables only, our whole world is connected these days.
Mm-hmm.
And even they have certain shares. For example, uh, let's say large ISP is there. For example, any company is saying, I have a branch office at United States. I want that branch office to be connected with India. That is
Okay.
connected only because of submarine cables, not because of any other things. Do you think these
Mm-hmm.
towers can be laid inside the sea? It's impossible.
No.
No, yeah.
And these radio waves have certain frequencies only. If you increase the frequency, what happens? Just imagine that thing. Have you seen a movie called Robo, if I'm not sure, Robo 3 or Robo 2, I believe, the radiation effect.
Okay, yeah.
Yeah.
So just imagine if I increase the frequency, what happens? Everyone will die, not only birds or animals, including humans. So
Mm-hmm.
that is highly impossible. This communication is only possible because of submarine cables. The whole world is connected only because of submarine cables. Okay. Now, mm, you can Google it and you'll find the map, entire map. Wherever there is a sea coasts involved uh, in the borders of India, let's say Mumbai, I believe, and in Andhra, Vishakhapatnam, Vizag, then Kerala or something like that. Wherever the oceans are there, right? There, sea levels, Chennai. So there, those parts, we have submarine cables laid. Okay.
Okay.
So because of
Yeah.
this, these days, the whole world is connected with faster communication. Okay. It's just a matter of buying those things, buying a particular share. Okay.
Okay.
Now, okay. Once this is done, we'll start with now. Okay. We are done with that part. Now we'll start with OSI model. Okay. OSI stands for Open System Interconnection. Basically, why this was introduced exactly? In olden days, there were two companies. Any two companies you can consider. For now, for simplicity, I'm considering Apple and IBM. So Apple used to have its own hardware and software. Similarly, IBM used to have its own hardware and software. So how about intercommunication between these two? The intercommunication was not possible in olden days. Okay, in order to make the intercommunication possible, OSI was introduced. That is the reason why OSI is into existence now. So in order to make inter-vendor communication possible, OSI was introduced. Okay, inter means, firstly, I want to make you familiar with the terms. Inter means different. Okay, intra means same. Now, vendor means a company. Okay, now what OSI will do to make the communication possible in between these two is, for example, Apple only understands French. IBM only understands German. In order to make the communication possible, OSI, what it does is it will convert this French into German, this German, vice versa, you can say, this German into French. So that is the way the intercommunication is possible. And it's not only about conversion. Behind that, it does many other things which are actually required for troubleshooting perspective, and which actually makes the troubleshooting easier, you can say that, for a specific network engineers. And this is the reason why it was introduced. And now for the question how we do that, we have this answer. Okay, now OSI has divided the networking. Okay, I'll write it for you. Networking processes into 7 different layers, namely layer 7, which is called as application, it's called as transport. Network layer, sorry, it is layer 3, right? Layer 2 is data link layer. Layer 1 is physical layer. So OSI has divided this networking processes into 7 different layers. So it follows a layered approach, which helps to easily identify where the uh, data is stuck or where exactly the problem is. Now, we'll understand each layer individually, but before that, we need to have the definition of OSI. It is how it is defined. Set of protocols. Or you can also call set of protocols which provides vendor interoperability. this way. Okay, this thing is clear.
Yes, it's clear.
Now we'll understand each layer individually. That let's take. Okay, first we'll go with application layer. Now, under the application layer, what does layer actually do? But before starting that concept, you might be having question of how to remember these things. There are certain simple terms, or you can also call it as tongue twisters or something like that. In order to have the fluency in English, we use tongue twisters, right? In the same way, in order to remember these terms, we use this thing. All people seem to need data processing. Well, for this, you can develop your own simplicity terms of how to remember it. Okay. Now, let's start with application layer. So application layer, if we talk about application layer, this layer is all about meaning. All these services and protocols which are required by the application software or the operating system in order to communicate on the network. Now, there's a question which actually arises on what are these services and what are these protocols actually. Well, in order to explain that, let's say we'll take services on one side and protocols on other side. It means application layer. Okay.
Okay.
By using mm,
SMLP.
okay, you can say IMAP
Okay.
SMTP. It's not SNMP.
SMTP. Okay. Okay.
And POP 3 means POP version 3. Okay. Nextly, telnet SSH. Email service, file service, remote
Data transfer using HTTP.
web service.
Yeah.
Okay, actually you can do this. Select this, delete it. Okay, so these are the services and these are the protocols. So if you ask me what is the application layer exactly, it is all about this. See the way I'm explaining it to you. Okay, firstly I have given you a simple term. Nextly I have given you the explanation for that term. Then nextly I have created a question in that and I have explained the answer in that.
Mm-hmm.
Okay, this completes your application layer. Any doubts in this?
No.
No.
Okay, are you clear with this thing?
Yeah, it's clear.
Fine. Now nextly we'll talk about presentation layer. Okay. Now this is also converts the data into standard format. For example, image file, JPG or JPEG, some format. You can assume any other format as well. Audio file, MP3, MP4, or something like that. Now, there's a basic standard which is followed here. ASCII, American Standard Code, something it would be there. I don't remember that term exactly, but this is how it converts. Okay, this completes your presentation layer. Any doubts in this? It basically converts the data into standard format. And what do you mean by that sentence? Is this layer ensures that data from sending application should be understood by the receiving application. In order to ensure that particular task, this does conversion process. Okay. For example, I've just considered an image file here. You can also consider audio or video or some other files. Okay.
Okay.
Now, nextly, we'll move to session layer. session layer. This session communication I've explained this to you earlier. Okay. Fine. So this is all about session layer. It'll just create the session, maintain the session, and terminate the session. Means I would say, let's say, if you take the example of two things, one would be sender. Let's say A is the sender, B is the receiver. In between A and B, what type of session is required? Is that session full duplex session? Full duplex session in the sense at a time anyone can transmit and receive. Okay. Is that half duplex session? At a time only one can transmit. Is that simplex? Only A will transmit and B will just listen. So that type of session. Okay.
Okay.
Is everything clear up until session layer?
Yeah.
Yeah.
Clear.
Okay. Now we'll start with next layer, which is transport layer. We talk it. This layer offers end-to-end delivery of data. And what do you mean by end-to-end? He's talking about end device over here. Okay. And if you want the detailed explanation of that, I can give it to you right away. What does end-to-end mean is, let's say, for example, simple network design. I'm taking it. This is my PC, and it is connected to a switch. Then it is connected to a router. After this router, you have a cloud. Cloud means internet, an ISP, you can say. Then the same setup is at the other branch. For example, this is the communication between the PC sitting in US and between the PC sitting in India. Okay. Switch, and this is PC. Now, edge to edge means what is the last device in your network, means in your organization. That is called as edge device. Basically, it is called as edge router because router would be the edge device. Okay. And the similar manner, what is the edge device for this particular organization? That is the last device, and it is called as the edge device, which is, I mean to say, the device which is directly connected to the internet. You can say that. Okay.
Mm-hmm.
Now, if you ask me exactly what is an edge device, see, this is basically edge to edge communication. Only the communication in the internet is called as edge to edge. But communication from your organization to another organization via the internet is called as end to end. Am I clear with these lines?
Okay, yeah.
So
Yes.
if I want to communicate from this PC to this PC via internet, that is called as end to end, because there is no other device beyond it. This is the last device. Here as well, this is the last device. That's the reason why it is called as end device,
Okay.
right? So it is basically called as end to end. Am I clear between end to end and edge to edge?
Yeah.
Okay, fine. Now, so transport layer. Okay, now this transport layer is basically called as heart of OSI model. The reason why it is called as heart of OSI model, you'll understand it once I complete all the OSI layers.
Okay.
Okay, so there are two protocols involved in transport layer. One protocol is TCP. TCP stands for okay, transmission control. Sorry, I believe this is user datagram protocol. Firstly, we'll discuss about TCP. TCP is connection oriented protocol. And what does that mean, connection oriented? Connection oriented means any devices, for now we'll consider two. Okay, so any devices, any two devices, if they want to establish a connection, then they have to follow certain rules in order to establish the connection. Certain protocols establishing the connection with specific agreed upon parameters between the devices. It's, you can say that it's an agreement between your house owner and you. That example will make sense over here. So house owner would say that I'll only give you the house if you'll agree to these parameters which are mentioned in the rental agreement. Correct?
Mhm.
So exactly the same example suits over here for connection oriented protocols. And also,
Okay.
practically speaking, what is connection oriented is, in terms of in terms of TCP, the connection oriented means this thing. So connection oriented means this thing, which I mentioned here. Okay. And whatever we are discussing right now is only for TCP protocol. Okay. Now,
Okay.
what is this three-way handshake? So three-way handshake, let's say I consider two devices. Device A and device B. Firstly, a message is sent to device B, that is SYN. In which direction? This direction, towards B. Okay. What is SYN over here? SYN means synchronization. What does mean? What does that mean exactly? It it means that A is saying, hey,
Okay.
this is what does SYN mean. Okay, now what does B do for once that message is received is B will send an acknowledgement for that message. Along with that acknowledgement, he'll also send his SYN message. Okay, so now A will send an acknowledgement for the SYN message. So how does this look is, So in this manner. So what this acknowledgement is saying is simply okay. You can say, okay, let's connect. Fine. Now, if you observe these three messages, right? For every message, there is an acknowledgement. See these three steps. For sin, there has to be an acknowledgement. For his sin, there is an acknowledgement.
Mm-hmm.
So since this is three-step process, it is called as three-way handshake. And this is done only in case of TCP based protocols. The one who is using TCP. Definitely there is a three-way handshake involved. Okay.
Okay.
So since this is three-step process, 1, 2, and 3, it is called as three-way handshake. Fine.
Okay.
Now we'll start with four-way handshake. I haven't given. So this is. Now nextly I'll start with TCP four-way handshake. Why TCP three-way handshake is used is to this thing. Why it is used to establish the connection. Okay. Now, why TCP four-way handshake is used is to terminate the established connection. Okay. It is terminating only the established connection. It is not terminating anything else. Remember it in this manner. This four-way handshake only come into picture if there is a three-way handshake being done already. Means once the three-way handshake is done, there would be a data exchange after the three-way handshake. Okay. Once the data exchange is done, then formally they agree to terminate the connection. That is what is exactly the four-way handshake. And how do they agree is in this manner. One moment, I'll just explain it to you. How do they agree? Same devices, A and B. So basically what, firstly, let me indicate the directions. Fin means finish. What is finished exactly? Data transferring is finished. So once the data transfer is finished, hence I want to Okay, so why are they terminating connection is because of this reason. Because initially they have done three-way handshake for the data exchange. Now that data exchange is finished, so formally they are terminating the connection. Fine. For the
Okay.
same, he is giving an acknowledgement. Again, the fin message is having an acknowledgement. Also for the from device B, there is a fin message. This also saying the same thing, but he is sending the fin message just to agree to A. Now, if he is agreeing with A and sending the fin message, then what is the requirement of acknowledgement over here? Acknowledgement is only required to say that, okay, your fin message has reached me. Fine, or any confusion?
No.
Fine.
Now, like the way if you scroll up, what is the requirement of this acknowledgement when he's sending the SYN again? He'll send the SYN to say that from his point of view, he want to terminate the connection. He's sending an acknowledgement to say that his SYN message from A is received by him. Am I clear or am I confusing you in any manner?
It's clear.
No, it's clear. Yeah.
Okay. So you need to think in this manner. Only then you'll understand the concepts. Fine.
Okay.
Now, hope four-way handshake is also clear to you, right?
Mm-hmm.
Now,
Yeah.
for these two handshakes, there are two things involved. What are those things? Two things is okay, sequence number and acknowledgement number. For example, if I'm sending the SYN packet, for this SYN, there is a sequence number. Okay, I'm indicating it as SCQ. That sequence number is initially 0, and then there would be an ACK number that is also 0. And this is in which direction? This is in this direction. After that, oops, what is he sending for that in response? He'll send an acknowledgement plus a SYN message. For this thing, the sequence number would be 0, acknowledge number would be 1. Now, reason why I mentioned this is you better understand in this manner. Firstly, let me delete this. I'll say it as SYN and then ACK. Now, if you look at here carefully, this is the SYN message from device B. So that is initial SYN from device B, correct?
Yeah.
So hence my sequence number would be 0.
0.
Now, why my acknowledgement number is 1? So there is a simple formula. So I can write it like this. Acknowledgement number is equal to sequence number plus 1. next expected sequence number. So that's the reason why it is 1. Now, why the acknowledgement number is 0? This is in which direction? This is in sender's direction. But this acknowledgement is from the receiver's direction towards the sender. What he's sending is, hey, I received your SYN message. I am sending you the SYN message with sequence number 0. I am sending you acknowledgement number 1 because I've received this acknowledgement number 0. He's incrementing the acknowledgements. Am I clear or any confusion?
Clear.
Okay. Now, what would be my next sequence number and acknowledgement number if I'm clear, if you are clear in understanding?
1 and 1. 1 and 2.
1 and 2? How come 1 and 2?
No, 1 and 1. 1 and 1.
Correct. Don't be confused. It's simple maths. Sorry. 1 and 1. Okay.
Okay.
So this is the thing.
Okay.
So this would be in which direction? This would be in this direction. Same applies to fin as well. Fin messages. Okay. Now, I want to bring up 2 things over here. Let me finish off the states as well. Mm, This is 3-way handshake and this is one here. Okay. Now, are you able to see these 2 diagrams over here?
Yes.
Okay.
Yes.
This is for TCP 3-way handshake.
3-way.
Based on the messages, you can understand whether this is 3-way handshake or whether this is 4-way handshake.
Both are same, right?
No, they are different.
This has
Why they are different? Because of this reason. TCP three-way handshake is used for what?
To
Establish
establish connection.
Connection establishment. And four-way handshake is for connection termination.
termination.
Once this is there, like the way I told earlier as well, once the three-way handshake is done, only then you'll be able to see four-way handshake once the data transfer in three-way handshake is finished, or else you would not be able to see four-way handshake.
Okay.
Okay.
Okay. Reason why? What is the reason? Because if I have established the connection in specific agreed upon parameters, I need to terminate that in specific agreed upon parameters, right? Again, remember the example of rental agreement. Let's say
Okay.
I was in that house for 1 year. Now, every 1 year, the contract renewal would be there. And what the house owner will say is, say, if you vacate the house, you need to inform me prior to 1 month or 2 months, right? In between, if you are vacating the house, then he'll charge for something, in some other manner or something like that. But the charge is being secondary thing. What I want to say is, let's say 1 year is done. Now I'm vacating the house. I need to hand over the house the way he has hand over the house to me, right?
Okay. Yeah.
Yes.
With the specific agreed upon parameters again, the same thing. I need to terminate the connection. You're terminating with your house owner, right? Nowhere you will be in contact with him again, right?
Yeah.
Yeah.
The same thing.
Okay.
Okay. So don't say that these two are same. No, these two are different.
No, no,
But
no. The diagrams which you put, uh, the diagrams which you put, like the pictures,
okay.
Like they both have the fin command, so
pin command. So
that's
what we are saying, like this,
Oops, I have taken Fin. Okay. From
yeah,
Google, I have picked it actually.
yeah.
I didn't
Okay.
expect that. I was not concentrating on the message actually. Yesterday itself, I was taken. Just a moment. I'll search for the three-way handshake. One moment. Mm, where is that? Yeah, both were in same color actually. So that's the reason why I was confused. Now you see, there's a difference, right?
Yeah.
yeah.
I'm sorry, my bad. I was mistaken.
Okay. Okay.
So this is three-way handshake and that is four-way handshake. So now there are certain states involved at the backend actually. So beyond this message, we are clear with this messages and sequence number concept. Okay. But now along with this messages, how the states are changed by the devices. On each and every device, there is a specific state once the SYN is received, once the SYN ACK is sent, once the ACK is received. Okay. So now, like I told, the connection is established, right? That is a specific state actually. Now,
Okay.
in four-way handshake, we are closing the connection. So that is also a specific state called closed state. Okay. So
Mm-hmm.
in order to go into established state, how they are negotiating is first of all from the sender. So that sender in networking term, it is called as a source device. Okay. You can either call it as source or you can either call it as sender. No worries. It depends on your understanding and your explanation. No worries. Okay. For simplicity, I'm calling it as sender. So now the sender is sending the SYN. So he'll go into SYN's send state and sending the SYN
Okay.
message. Now, once the SYN is received, the receiver is going into SYN received state. And after going into that state only, he's sending SYNACK message to the sender. Once the sender receives SYNACK message, he'll send ACK message and he'll go into established state. Once this receiver receives this sender's ACK message, he'll go into established state.
Established. Okay.
That's all. It's very simple. Okay. It's not at all complex or anything else. It's very simple. Just depending on your understanding logically. Okay. Once SYN is sent, he should mark something, right? Okay, I've sent the SYN. So he'll go into SYN send state. Once the SYN is received, he'll mark SYN is received. Okay. Now, what is my next state? My next state would be established because I have received SYNACK. I don't have any more to receive. That's the reason. In the similar manner, once the ACK is received, he don't have any more messages to receive. That's the reason why he's going into established state. And this is once this is once both are into established, the three-way handshake is done. Then they'll begin the data exchange. Once the data exchange is done, they'll go into four-way handshake process in order to close the connection. And for this, there are some messages, 2 or 3 extra involved over here in order to terminate the connection. Okay.
Okay.
So here, this is established connection. Established connection means they are in these states, right? So they are in established connection state. Now, they want to go into termination state, or you can say close state, or whatever you call for simplicity. So for that, he'll send he'll go into FinWait1 to actively close the connection. Now, once the fin message is sent, he'll go into FinWait1 and he is actively waiting. The sender is actively waiting to close the connection. Now receiver is not doing anything. He's just accepting what the sender is sending. He's just proceeding depending on the sender's messages. He's not sending any messages on his own, right? He's just acknowledging and he's agreeing to whatever the sender is sending, correct? He's not taking any decisions on his own, right? If you
Okay.
observe logically and carefully. So he's initiating the connection of termination, which is fin message. So he's actively closing the connection. He's waiting for that connection to close passively, not actively, because he is not responsible whether to close the connection or whether to begin the connection. The connection is begun by whom? Initiator.
Initiator. Okay.
Connection is terminated by whom? Who would want to terminate the connection actively? Initiator again. So that's why it is active close. He is agreeing, B is agreeing to initiator. I mean, the receiver is agreeing to initiator. That's why it's passive close. So he'll go into close wait state once the fin message is received. From which state? From the established state. Okay. Am I clear or any
Okay.
Yeah.
confusion?
Yeah.
No.
Okay.
Clear.
Now, once in close wait state, he's sending what? Acknowledgement for the fin message received. Once that acknowledgement is received by the initiator, he's going into FinWait2 state. Okay. Again, he's sending another message. What message? Again, he's sending fin message from close wait state, but he'll go into last act state and then send the fin message. Okay.
Okay.
Reason why last act? Because he has to receive what? Last acknowledgement in order to close the connection. Now, once the ACK is received, he will go into FinWait state Once the fin is received, he'll go into time wait state and he'll send an acknowledgement. Now, there might be a question. Why time wait state instead of going into closed state directly? Because he don't have any other message to be received, right? Why time wait again? Because he has to wait for this acknowledgement to be received by the receiver. Am I clear?
Okay. Yeah.
Yeah.
What he's doing in this time wait state? He is starting a timer. Irrespective of this acknowledgement message received by the receiver, I'll close the connection once this timer is expired.
Done.
Yes, you
Okay.
can say done or expired.
Okay. Understood.
Are you clear with both of these? TCP three-way
Yeah.
handshake and four-way handshake along with the states.
Yes.
Okay.
Yes, it's clear.
Okay, fine. Awesome. Now, once this is done, there's a concept in case of TCP called segmentation. So what is this segmentation all about is, so basically definition should not be like this. There should be a meaning for that. So okay, each segment is assigned with a particular sequence number. Now,
Okay.
practically speaking, what exactly is happening? I have a large amount of data, for example. This is my data. I'm dividing this data into what? Multiple smaller segments. Okay. And to each segment, what I'm doing, I'm assigning a specific sequence number. Why am I doing that? To,
To differentiate
to differentiate what?
like the data.
Not exactly differentiating the data, but there is
To
one more important reason
arrange
behind
it
that.
in order.
Correct. If let's say the order might be mismatched, right? So how will the receiver understand? Oh my God, all these segments belong to same segment. Sorry, same data only. But how come I'll understand what is next? What is an order of this exactly? In which order do I need
Okay.
to arrange, right? In order to arrange the segments back in correct order at the destination, this sequence number is necessary. Okay.
Okay.
Mm-hmm.
Now, okay, I have received a large data. Then I have divided the data into multiple segments, and to each segment I have assigned a specific sequence number for the receiver to understand it and to arrange the data back in correct order, to arrange the segments back in correct order at the destination. That's fine. Now, there might be a question. What is the uniform size of each segment? There has to be a size, right? I cannot divide it as per my requirement. There has to be a by default size, right? To which I have to divide the data. So
Mm-hmm.
that size is called as, the size is defined by MSS. MSS means maximum segment size.
Okay.
Maximum segment size. What what does it specify is it is defined as the maximum okay, and by default what is that size? That means my each segment size should be 1460 bytes, not more than that. Clear?
Okay. Mm-hmm.
So this way. So by default it is 1460 bytes. So this is all about segmentation and maximum segment size. Now, in case of MSS, what happens is I'm sending segment one. I'm expecting acknowledgement one. I mean, acknowledgement for the segment one which I have sent. Again, I'm sending segment two. I'm expecting acknowledgement for the segment two. I'm sending segment three, acknowledgement for segment three. Reason why I'm saying this or why I'm mentioning this is basically I want to highlight that device A, after sending each and every segment, he has to wait for an acknowledgement for the segment which he has sent. So that is painfully making TCP very slow, right? Because
Okay.
once that
Yeah.
is received, then he'll process, then he'll send an acknowledgement. That is very painful part for the TCP. So in order to make TCP little bit fast, another concept was introduced. That concept is called windowing. Okay. Now what happens in windowing is, firstly, the definition for windowing is something like this. The quantity of data segments measured. Measured in what? Measured in bytes. Okay. The transmitting machine or the sender, you can say, for simplicity. Before receiving an acknowledgement. Meaning, what I'm trying to say over here is the quantity of data segments I'm continuously sending. Who is sending? Sender is sending to the receiver before receiving what? Before receiving an acknowledgement.
Okay.
So how many he can send? This size is called as 4128 bytes at the time he can send before receiving an acknowledgement from the receiver is called as windowing. So where is 1460 and where is 4128? There's a lot of difference, right? This each segment which I'm sending is only 1460 bytes. Okay, then acknowledgement for that. Then 1460, then acknowledgement. Am I clear? In case of what? In case of MSS. But here in case of windowing, it's not like that. It's all about sending 4128 bytes at a time. Then once the 4128 bytes is done, then he's sending an acknowledgement. And one more thing, this windowing definition could be mentioned from sender's perspective or from the receiver's perspective as well. If you define this from the receiver's perspective, how the definition would be maximum amount of data segments measured in bytes the receiving machine is allowed to receive before sending an acknowledgement. You can mention in this manner as well. Am I clear?
Okay.
Yeah, clear.
Okay. Ritesh, are you clear?
Yeah, I am clear.
Okay,
I
fine.
understood it.
So this is how it is explained in both the ways. You can say it's up to you, but you need to mention specifically. Let's say if windowing definition from the sender's perspective, then you need to answer that. Windowing definition from the receiver's perspective. Okay.
Okay.
Now, normally what happens, how this is done is, for again, the same example. Oops. So normally what happens is, let's say segment 1, segment 2, segment 3. Now, usually each and every device do have a buffer. Buffer is nothing but a memory to store these segments which are sent. And that is called as interface buffer basically to an interface. Yesterday I've shown you something called NIC card, if you remember.
Yeah.
So that NIC card will be having a memory called buffer, which is called as interface buffer.
Okay.
Okay. So that interface buffer is something like this, you can see. Just for understanding, I'm mentioning it in this manner. Okay. So normally what happens is, this is a buffer. So whatever is sent, I'm filling out this thing. Segment 1, then followed by segment 2. These are the segments. Okay. Once this buffer is full, then the device start processing the data. Means then the device will take the decision of what to do with this specific data which I have received. Okay.
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 So until and unless this buffer is full, he won't process the data. This is the basic scenario. Okay. Basic understanding. Fine.
Yeah.
Okay.
Now, because of windowing, what is happening? See here. At a time, you are sending 4128 bytes. What if the buffer is not capable of this 4128 bytes? For the first set of 4128 bytes, it is capable. For the second set, it is not capable. Then in that case, what happens? The same thing, buffer overflow happens, right? Buffer will overflow. Let's say if you have opened a tab in a bucket, let's say the bucket capacity is around 5 to 10 liters. Let's assume it as 5 liters. Okay. Once that 5 liters is done, once the bucket is filled up to 5 liters, what happen if you won't close the tap? That will be overflowing, right?
Yeah.
So what happen
Yeah.
if I don't stop the sender from sending the data? The same thing happens over here. I have to stop the sender, right?
Mm-hmm.
Yes.
Why I'm stopping the center? Because my buffer
It
will overflow.
overflow, yeah.
Okay. So for 4128 bytes, first set is okay. In the second set, I am facing this problem of what? Buffer overflow
Buffer
problem.
overflow.
So I'll send a message to the sender. What is that message? Is ECN stands for error congestion notification. For human understanding purpose, what does this ECN mean is okay.
Okay.
Now there is a question which will come. Till what time the sender will stop sending the data? Okay. He cannot stop sending for lifetime, right? There has to
Yeah.
be
Mm.
something, some limitation for that. That limitation is till another message is sent from the receiver to the sender. That message is CWR, means congestion window reduce. For human
Okay.
understanding purpose, how this is understood is okay.
Okay.
Now
Okay.
this concept is nothing but congestion control in TCP. Okay.
Mm-hmm.
So, and you'd have the types of acknowledgements, which I'll discuss tomorrow. Okay. For now, we'll discuss what are port numbers. So port numbers are is a 16-bit value. Okay. Port numbers are of 16 bits. So 2 raised to the power 16. So it will be around what number? 65536.
6,
But it actually ranges from 0.
0 to
So
3,
65535.
5.
Now these are divided into different categories. Those categories are three categories. Okay. Generally, you'll find only two categories but for me, it's three categories. How is like this: well-known port numbers. Okay, first category. So under well-known port numbers, you have the below range 0 to 1023. You have well-known port numbers. Then you have reserved range, reserved port number range, or reserved port numbers. So under reserved port numbers, the range is from 10242 to 49151. Now, another category is random port numbers. So under random port numbers, you have the range from 49152 to 65535. So these are the three categories. So these are reserved for NAT and traceroute. NAT means network address translation. Oh man. And other thing is called as trace route. In order to trace the path from source to destination, this trace route is used. You'll understand the trace route later on because we'll discuss it late in forthcoming days. So firstly, what are these well-known port numbers? Like the way I was mentioning some protocols, right? For Telnet, the well-known port number is 22. For SSH, the well-known port number is 23. For HTTP, sorry, the well-known port number is 80. For HTTPS, the well-known port number is 443. For DNS, the well-known port number is 53. For DHCP, the well-known port number is 67 and 68. For SMTP, sorry, the well-known port number is 25. Okay, and there are certain, so you will find the map of the port numbers. One second. If you type port numbers list in Google, you will have different protocols and different port numbers along with the protocols which okay, how to take this? Okay, are you able to see this?
Yes.
This one. Then apart from this, just a minute. So these are the port numbers which are used depending on the protocols, and the port numbers are only for the protocols which are for layer 7. Means port numbers will only be for the protocols if those protocols are from layer 7. Okay, only for the application layer protocols. These are all the application layer protocols, and they use TCP at transport layer. SSH uses both TCP and UDP at transport layer with the port number 22. So these are the things. These things you need to remember because these are by default port numbers. These can be customized depending on the requirement of the organization as well. Okay,
Okay.
you'll find complete list of port numbers. Just to explain it to you, I have taken this snip. Okay,
Mhm.
so this is all about port numbers. I guess it's 8. Okay, if you have any doubts in the class today which I have discussed, you can ask. If not, we can wind up.
Yeah, no doubts until now.
Okay, is
No
everything
doubts.
clear up until this
Yes.
point?
Mm-hmm.
Yeah, it's clear.
of my language and explanation. Is it clear to
Yeah,
you?
yeah, it's clear.
Yeah, it's clear.
Fine. Okay, then we'll wind up for today. Then let's meet tomorrow. Please do revise these things. Okay.
Okay, okay,
If
sure.
you won't
Okay.
revise, then next concepts would be like what I could say. Those will be going under top of your head. Sorry, over top of your head, not under.
Okay,
Okay.
So, and I can repeat any concepts if you want, but please do revise this. Okay.
okay, sure.
Okay, then have a nice day. Please do take care and stay safe. Bye bye.
Bye.
Thank you.
Thank you.
You're welcome. Bye bye.